All right, today we're cracking open a fascinating case file, the Great Indian Climate Puzzle. Think about it for a second. You've got a country that's home to both the wettest place on the entire planet and a massive, scorching hot desert. How on earth does that happen in the same place? Well, that's what we're here to figure out. Let's start digging.
Okay, just take a look at this. On one side, you've got these incredible green hills, just drenched in moisture. You can practically feel the humidity through the screen, right? And then you look at the other side, a bone-dry, sun-baked road stretching out into nothing. And the craziest part? This isn't two different continents. This is India. This huge contrast? Well, that's our first big clue.
So that leads us to the big question, the central puzzle we're trying to solve. What single force could possibly be powerful enough to create these wild extremes? Now, spoiler alert, it's not just one thing. It's more like a whole crew of forces, all working together, and our job as detectives is to figure out who they are, how they operate, and, find the real mastermind behind this whole operation.
All right, so here's our game plan for this investigation. First, we'll look at the big picture, the main forces at play. Then, we're going to zoom in on the main event, the monsoon. We'll also see how this all affects everyday life, what happens when things go wrong. And then, we'll put you to the test.
Okay, let's get into it. First up, the forces of nature. Think of these as our key suspects. Now, these are the basic building blocks of climate everywhere in the world. But in India, it's like they're turned up to 11. Everything is just more extreme. Suspect number 1 is latitude. It's really all about your distance from the equator. Imagine the sun is a giant flashlight. Near the equator, that light is hitting straight on. It's super focused and intense. That's why southern India is so warm all year round. But as you move north, that beam hits at more of an angle, spreading the same amount of energy over a bigger area. So you get those distinct, cooler seasons up north.
All right, on to suspect number 2, altitude. You can think of this as the mountains chill. And the science is pretty simple, really. As you go higher up, the air gets thinner, less dense, and that thin air just isn't very good at holding on to heat. So the higher you climb, the colder it gets. It's a pretty reliable rule.
And here's a perfect example of what I'm talking about. You've got these amazing hill stations like Munnar. People flock there to escape the heat, and for good reason. Even though Munnar is at the same latitude as some sweltering city down on the plains, its high altitude is like a built-in air conditioner. That's the mountain's chill doing its thing.
Now, for our third suspect, let's call it the ocean's embrace. The ocean is basically a giant temperature regulator. See, water takes a long time to heat up, and it also takes a long time to cool down. This means it acts like a giant stabilizer for coastal areas, preventing them from getting crazy hot in the summer or freezing cold in the winter.
And hey, don't just take my word for it. The numbers don't lie. Check this out. If you're in Mumbai, right on the coast, the temperature only swings about 14 degrees Celsius throughout the year. Pretty stable, right? But then you go inland to a city like Nagpur, and whoa, that range explodes to a massive 34-degree difference. That's what happens when you don't have that ocean's embrace to keep things in check. And we can't forget a couple of other key players here. The accomplices, if you will. You've got winds, which are kind of like a climate delivery service. Sometimes they bring hot, dry air from a desert. Other times they bring cool, moist air from the sea. And then there's the land itself, the topography. This is huge. The Himalayas, for example, act like a massive wall, literally blocking those frigid winds from Central Asia from sweeping down into India. So, let's recap our suspect list. We have latitude, altitude, the sea, winds, and mountains. They all definitely play a role. But in any good mystery, all the clues eventually point to one prime suspect, the one pulling all the strings. And in this case, it's time to meet the true mastermind behind India's climate, the Great Monsoon Engine.
Okay, this is super important. When most of us hear the word monsoon, we just think rain, right? A ton of rain. But the rain is just the effect, not the cause. The monsoon itself is actually this massive seasonal reversal of wind patterns. The word Mawsynram even means season in Arabic. So think of it as this giant engine in the atmosphere, and the famous downpours are just what comes out of the exhaust.
So how does this engine actually work? Well, in the summer, the huge Asian landmass gets absolutely baked by the sun, heating up way faster than the ocean does. This creates a giant area of low pressure over the land. You can picture it like a massive vacuum cleaner. And nature hates a vacuum, so it pulls in all this cool, wet air from the high-pressure zone over the ocean to fill the gap. When that moist air hits the hot land, it rises, cools down, and boom, you get those legendary monsoon rains.
And you can see that complete reversal right here on these maps. During the summer, the southwest monsoon is pulling all that moisture in from the sea and dumping it onto the land. But then winter rolls around and the whole engine just flips. The land cools down, creating a high-pressure zone that pushes dry air back out to the sea. It's a complete 180 every single year, like clockwork.
And if you want to understand the raw power of this engine, just look at this number. Seriously. In a place called Mawsynram, the wettest place on Earth, they get an average of 11,000 millimeters of rain a year. That's 11 meters. To put that in perspective, that's like the height of a 3-story building. That is an unbelievable amount of water falling from the sky. That is the monsoon engine at full throttle.
Okay, so we've got our prime suspect, the monsoon. But the investigation isn't over, not by a long shot. Now we have to understand the why. What's the impact? How does this incredibly powerful climate system shape the lives of more than 1 billion people?
I mean, the entire rhythm of life in India is tuned to this cycle. You see it in everything. Major festivals like Baisakhi in the north, Onam in Kerala, Pongal in the south, they're all connected to the harvest seasons, which are completely dependent on the monsoon. For millions of farmers, a good or bad monsoon can literally be the difference between a good year and disaster. This isn't just about the weather. It's the very heartbeat of the subcontinent.
But of course, like in any good detective story, there's a plot twist. This powerful, life-giving system, well, it has a dangerous side. And what's more, a new villain has shown up on the scene. One that's messing with this ancient, finely tuned machine in ways we're only just beginning to understand. See, when this system goes into overdrive, the results can be devastating. The very same forces that bring that essential, life-giving rain can also intensify and turn into catastrophic floods or incredibly powerful cyclones, leaving a trail of destruction behind. And that new villain? It's climate change. You see, unlike all the other suspects we've looked at today, this one isn't entirely natural. It's being supercharged by human activities. And its whole MO, its method of operation, is to take these existing weather patterns and make them more extreme, less predictable, and a whole lot more dangerous. And the evidence against this new villain is pretty overwhelming. We've got Exhibit A, burning fossil fuels, and Exhibit B, massive deforestation. Both of these pump tons of greenhouse gases into the atmosphere. You can think of these gases as a blanket around the Earth that just keeps getting thicker and thicker, trapping more heat and throwing the entire global climate system completely out of whack. And all of this brings us to our final challenge. We've laid out the case, we've gone through the evidence, we've identified all the suspects, so now it's your turn to play detective. Let's review the case file and see if you can solve one last piece of the puzzle. So here it is, the last question from the case file. Why is Chennai, down in the south, warm pretty much all year, while Leh, way up in the north, is so cold? Got to figure it out? It's a team-up of our top 2 suspects. Chennai is at a low latitude, close to the equator, so it's getting that direct, powerful sunlight. Meanwhile, Leh gets hit with a double whammy. It's at a much higher latitude, and it's at a super high altitude, so it gets less direct sun and a serious dose of the mountain's chill. And with that, case closed. I want to leave you with this ancient Sanskrit prayer. What it shows us is that for thousands of years, people have understood a really deep truth, that a stable, predictable climate is the bedrock of everything, of prosperity, of peace, of life itself. The great Indian climate puzzle, it turns out, isn't just a cool science lesson. It's a timeless story about survival and our ability to adapt. And as we've seen today, it's a story that is now facing its biggest challenge ever.